Just think about real quick how we got that p-value. I got the t-score from typing it in that formula. The p-value I got by doing a TCDF. Alright, so let's go to our TCDF distribution. So second vars pulls that up, and I want TCDF. Okay, now this time we got to think about what type of number we're dealing with. I have a negative t-score, which means I'm on the lower half of my graph. So I want anything from negative infinity all the way up to this negative 1.576. So negative 1 e to the 99. So what we're going to type in for negative infinity. And then for upper, I want that to be negative 1.576. Degrees of freedom would be n minus 1. I don't know what I'm typing in there. So that'd be 6 minus 1, so it's 5 degrees of freedom. And then I'm just going to hit enter. And so those that don't have this nice fancy calculator can make sure you type that in correctly. And when I hit enter, I get 0.0879 or 0.088, which is where I got that number from a second ago. Okay. Now, with an alpha of 0.1, so we just have to think for a second, is our p-value less than alpha or greater than alpha? Okay, and 0.08 is actually smaller than 0.1, so this is a p-value that we think is statistically significant. So our conclusion then we would be, since our p-value is less than alpha, I reject the null. And now what does that mean in context then? There is sufficient evidence to suggest that the true mean COLA is less than 300 milliliters. Okay, so in other words, there's enough evidence to suggest that they are underfilling the bottles. So where they go next, I don't know what kind of crime that is, but there definitely is evidence to suggest there's something like that going on. Okay, let's take a look at a second example. The degree of reading power, DRP is a test of reading ability of children. Here are the DRP scores for 44 random third graders in a suburban district. And that's the data that's actually in your note page right there. At an alpha of 0.1, is there sufficient evidence to suggest that the district's third graders' reading ability is different than the national mean average of 34? Okay, so before we go any further, let's take a minute and actually just type in these numbers into our calculator and get a good sense as to what's happening with it. Okay. Okay, so we're going to enter in these numbers. So we want to go to Stat Edit. We want to go to List 1. So I've actually got something still in there, so let me delete that out. And I'm just going to type in all of these numbers. So I'll let you watch me for a minute, but then I'm going to pause this. It's not that exciting to watch me type in numbers. So feel free to pause the video on your end and type in the numbers into your calculator just so we can kind of do this process together. Okay, so I've got all my numbers typed in. One thing to look for is you should see 44 when you get all the way said and done. And we're going to come back to this in a moment. Well, actually, let's go ahead and do one var stats on this so we can get the numbers we need for the sample. So go to Stat, Calc, and then one var stat. And then just want to make sure it's on list 1. So when I hit enter, I get a mean of 35.09 and a sample standard deviation 11.19. Is that number right there? So kind of keep those numbers off to the side and we'll kind of use those more in a minute. Okay, so let's check assumptions first. Do we have SRS? Let me go way back in the problem. They actually told us right at the beginning that it's a random sample of 44 third graders, so we're good there. Normal, well, we have a large enough sample, so it's one way we could do it is just say, well, sample's large enough, so the sampling distribution is approximately normal. Or if I wanted to do a histogram or a box plot, we could have also done that, but that isn't necessary to do more than one confirmation method as far as normality is concerned. Do we know sigma, the population standard deviation? And if you look back at the question, nowhere does it talk about the population standard deviation at all, so that is an unknown factor. What about our null and alternative? Okay. Well, we are comparing this set of reading score sample to the national average. So we want to check and see if it's evidence that it's actually different. So different would imply a two-tell test. And then our null would be 34, and then we just want to define mu as the true mean reading ability of the district's third graders. Okay, so from here we're going to plug in all those numbers that we just calculated into the calculator. So the sample and the standard deviation that we got, and then the square root of 44. So let me pull up my calculator here. Okay, so I'm going to go to the TCDF and go pick number 6 here. Okay, so let's talk about that t-score. It's a positive number, which means I'm on the upper tail part of the graph. So I want to know from point 646. Sorry, let's try that again. 0.6467 is going to be the lower bound. The upper bound is going to be our infinity, so 1e to the 99. Degrees of freedom in this case would be, we got a sample of 44, so n minus 1, 44 minus 1 is 43. And then I want to hit paste, so I hit enter. So for those that don't have a fancy calculator, that's the one those are the numbers we want in our formula. And interestingly enough, when I hit enter, I get 0.26, but this is a two-tailed test. Remember that not equal to sign. So I actually need to take this and double it. So I get a p-value of 0.52. Okay, now let's think about this as in terms of alpha. We said alpha is 0.1 for this particular problem, which means we're not going to get excited about the data until I have a p-value, a probability of less than 10%. Well, I happen to have a sample that would show up about 52% of the time. So clearly this is nothing to get excited about. So our conclusion, we're going to start with comparing the p-value and state the decision. So since the p-value is greater than alpha, I fail to reject the null. And then in context, this means there is not sufficient evidence to suggest the true reading ability of the district's third grader is different than the national mean. Okay. Tie in a previous context. What type of error could we have made with this particular problem? So I failed to reject the null. So if I fail to reject, that's actually a type 2 error, and that's when we decided that the true mean is not different than the national when it really is. So anyways, just a quick review of type 2 error. If I wanted to do a confidence interval to match these results, what kind of confidence interval would I want? So again, we have an alpha of 0.1, so I just need to make sure it matches the middle. So that would be a 90% confidence interval. And if we compute that, so let me get out my calculator again. Okay, so to get to the confidence interval menu, we want to go back to, let's see, we want to go to tests actually, and we want a t interval, so that would be number 8, and we would input the stats that we got from our problem of the mean and the standard deviation and sample size. So let me pause this. Okay, oddly enough, my calculator by default put all this information in. So we already calculated the sample mean to be 35.09. The standard deviation of the sample was 11.19, and the it's actually 44 in the sample. And then we got the confidence level of 0.9. So when I calculate that, I get 32.25 to 37.927. Which, if we think about that in context, the national average is 34. 34 is within this interval. So is there evidence that it's different than the national average? Well, the national average fits in the interval, so we don't really suspect there's anything different about that. Okay. Okay, let's look at another example. The Wall Street Journal reported that based on sales in a chain of Midwestern grocery stores, President's Choice of chocolate chip cookies were selling at a mean rate of $13.23 per week. Suppose a random sample of 30 weeks in 1995 in the same stores showed the cookies were selling at an average of 1208 with a standard deviation of 275. Does this indicate that the sales of the cookies are lower than the earlier figure? Okay. So let's jump through the hoops and just make sure that we understand what we're dealing with here. So let's just talk through, do we have an SRS, and it does state the word random in the problem. Do we have a normal sample size that's normal, and in this case with 30 weeks, sample size is large enough to be normal, and nowhere does it say that the sigma is unknown. Okay, so as far as assumptions go, we're good. What about everything else? Well, let me kind of put up the worked out solution so you can kind of see what the process looks like from start to finish. We are trying to see if the mean number is less than 1323, and so we would calculate our t-score to be negative 2.29, and when we do a t-CDF of lower tail, we should get a p-value. And so that's what our conclusion would be. Since p-value is less than alpha of 0.05, I reject the null. There is sufficient evidence to suggest that the cookie cells are lower than the earlier figure. And then again, to tie in a previous question, what type of error could we have made with something like this? Well, since we set out to show that it was lower, then if we did make an error, that would be a type 1 error. And the consequence would be that we think the sales have dropped. Now, in a company situation, if you think the sales have dropped at a particular store, what are you going to do? You're going to start letting people go. And that's a pretty severe consequence if you think the sales are not quite up to where they should be. So, anyways, that would be that. Okay, continuing along with this example, let's see. So, same information. What would a 90% confidence interval look like? And I think that one we can go to our calculator. And let's compare. So let's go to stat tests, and we want a t-interval. Alright, and we're going to input the stats independently. So in our mean is 1208. Standard deviation is 275. There are 30 n, so sample size of 30, and we're doing a 90% confidence interval. And I missed it. Let me try that again. I got so excited that I hit the button. So let me go back over to the test. So t-interval, okay, so I just need to hit enter Stop hitting enter. Okay, so the calculator does it, and we get 1122.7 to 1293.93. Okay, and one sort of question to think about is 1323 in that interval, and it's not. So it's safe to say that the population mean has changed based on this interval prediction, which is what our hypothesis test said. Our hypothesis test said we had a very low p-value, and there was evidence to suggest that it was lower. Our confidence interval also matches that conclusion. Okay.